out onto the internet. Everything is running, this version is running Llama. It's running the Gemma 3 model. It's running Whisper CPP. And the whole idea is to capture one side of a conversation and measure and see how I'm doing. So I do have slides, so I apologize for breaking. In the title, there was originally like Luchador or something that I was talking about. That was 2 weeks ago. I've moved on from Luchadors. So this new one is a video game theme. I did create an N8N application. I got tired of guys posting their N8N workflows without the code. So if you just upload, if you go to Lucha at Janishek, my last name.com, just drag and drop an image and it'll generate the workflow for you. And then he can even give you a shopping list of what credentials you need to go get to have the workflow work. So passed on. Big thing, software application that I love is called Granola. It's essentially like a Google Meeting or a Zoom monitor. It captures every word you say, every transcript. I love it, except when they wanted $20 a month for it. And then they wanted another $20 for everybody on the team. I get it, but there's not that much functionality to have me want to pay 20 bucks a month. So I decided to build it myself. I also didn't love that they raised $43 million. That just means that their software is going to get really fat and over-promise, maybe over-deliver. So I didn't want to have that on my PC at all. Software replicators, if anybody loves Star Trek, like I love Star Trek, we thought we were just going to have Earl Grey hot and food being generated, but we're doing software replication, right? So why would you give Microsoft $1 for Microsoft Office when I can click 2 buttons and build out 95% of that functionality for free, right? So we're eating ourselves. So this is the state of the art in AI. Everything is a text area field. A guy named Luke Woborowski, I never pronounce his name right. This is the state of the art. We don't have interfaces for our AI. Everything's a text area. Well, what do you want? I don't know what I want. Right now, you have to tell it what you want. So I built this agent thing out. It keeps me from saying something stupid. Make sure my meeting, I hit my goals. How many times have you had a meeting and you forgot to say, oh, dude, I didn't do this? And then I wanted something fun. I'm tired of text area. So what if Dieter Rams, he's a mid-century modern designer that I love, played video games, did mission briefs, and then I built out this application. So I'll show you how it works right now. And hopefully I'm doing this right. This is how we show and tell. I don't know. So this is Kochi. Just made up a name. It's a mix of mid-century modern design and old school video games. There's about 100 different reactions that my general here can do. I start a meeting, introduce a product, check pricing. I can control what I want my goals of the meeting to be, and start recording. So it's tracking everything I say. There's a transcript running. Whisper is capturing speech to text. It's submitting it to Gemma 3 every 15 or 20 seconds. Let me check my timeline. I just introduced the product, it checked it off. So as I'm working through my goals for the meeting, it checks it off. The beauty is, the code is 5 megs in size. The models are, 1.5 gigs, downloadable from Hugging Face. Something tomorrow is better than Gemma 3, cool. I'll download it. This is only the 1 billion parameter model that I'm using, so it runs on my crappy MacBook Air. So that's the idea of this. No tracking, so you can save. Let me end my meeting here. It saves the transcripts, it saves the MP3, and it cost me $0.00. Tech stack, like I said, Whisper. I'm running Olama. I can run Llama, CPP, maybe get a little bit more performance. Electron app, no internet required. And in the future, it doesn't have to be some military general. It could be Kermit the Frog. It could be my dad, your mom. It could be anybody that helps coach you through. So that's what I've been tinkering with. I want to put an interface on these prompts and have a little bit more fun. Any questions? Yes. That was it? Yes, sir. I was thinking about, I'm going to put it up online. Yeah, it's called GitHub. Jay Janishek, I got a long, dumb name, but if you look up Joey J, you might get to me pretty quick. Janishek for sure. Ask ChatGPT about me. Yes, ma'am. As long as it's not politics, yes. Sure. I'm Joey. Yeah, I'm hanging out. Yeah. Yes, sir.
The recording, did it have anything to do with the compliance issues while the person gets notified?
I don't record the system audio. I'm only recording my microphone. So I'm only recording a one-sided conversation. I don't care if they're more performant. I'm trying to make myself better. So I am curious about filling in the other side of the conversation based on my responses. I wonder how far you can get with that. So yeah, the idea is it works without the internet. Legally, there's nothing that the other person has to be concerned about. It's self-performance. It's an Apple Watch on a run. I'm making myself better. Yeah, I have sweat through this shirt. Any other questions? Thanks, guys. You? Yeah? Yes, sir.
So, you talked about interfaces, right?
Yeah.
You talked about this mini graphical user interface.
Yeah.
What other things, do you consider, what are the, do you consider any other tools that are already mature enough that are, in the market?
I don't know what is in the market, that kind of does it. This is really just an itch I wanted to scratch for myself. I didn't want to leave a meeting forgetting something. I wanted to at least have somebody tell me when I said that stupid thing that I'll do just about every meeting. And yeah, it was just something selfish for myself and mid-century modern and video games. Yeah. But the idea that it could be for a company, kind of leaning back to those politics that I was dealing with, they have all these people who call you. Probably going to be more robocallers now. It's going to be worse. But there's still people who will call you, and they have to check off certain things. Just having the ability to help train somebody, hit those 3 goals, and on to the next thing. Yeah. Cool. Senor? Yeah, thank you. Thank you.
Let's do a round of applause.
Yeah.
Whoever wants to go next.
Thank you. Nothing.
You need dongle?
Yeah.
Hey guys, I'm Curtis. I software engineer for 20 years. About a year and a half ago, quit my CTO job and went all in on AI. Been doing that ever since. I have a AI agent platform that I've been working on for 10 months now, which is forever. So what we're going to be talking today is fractal agent swarms and how those can potentially bootstrap into ASI with some advances in the underlying LLMs, right? And so basically we're going to start out with let's talk about what, so agents, right? We all know what agents are, but when we break down agents into their simplest form, there are 3 primitives. We have instructions, tool names, and message history. And so to make an agent, all you need is basically a code loop that takes those instructions, tool names, and message history, sends it to the LLM, gets a response back, processes the tools, handles errors, and then goes through another loop. That's all an agent is, right? And so with these 3 primitives, what we can do is we can essentially have a common runtime for all agents, and all agents are defined in a simple JSON file, right? So you need the tool code to execute. You need the runtime to do the loop, but that's all an agent is. And you can build any agent with this simple structure. And so the important bit here is that with this simple structure, you can potentially see here how you can easily make one agent that creates other agents or edits other agents or monitors other agents and tweaks their parameters, or as another agent is doing something, it injects new instructions into the agent at a certain runtime, right? And so now we can have sort of meta agents, right? Agents that are monitoring, creating, or modifying other agents in certain ways. And so as you start to build and layer that out, it becomes pretty powerful. So one of the core ideas of sort of what I'm building is this concept that more specialized agents produce better results, right? And so that's like the core tenet of any agent swarm potentially ascending to ASI, right? So what we're going to talk about here is I'm going to do a quick demo, and what I've done is I've used a generic coding agent, Claude Code. Claude Code isn't specifically built to do any particular coding task. It's just an agent that's built to do code, to write code, right? So we have Claude Code, and so this is, I just one-shotted Claude Code, hey, build me a tower defense game in JavaScript, right? This is what I came out with. It's pretty good, right? So like it's a functional tower defense game. We can build towers, the towers shoot the things, they go through, and so like functional basic tower defense game. So then I took it one step further and I said, like, okay, ask me questions so that you can create a more complicated tower defense game, right? And so it came back, asked me questions like what technologies do I want to use, what features do I want it to have, and I gave it a pretty complex set of features, like I want to build different types of towers, I want the guys to get more powerful, and it still made a more or less functional game, though there's some bugs. The more complicated feature set, and so this is a one-shot, not normally how you'd use Claude Code, right? Usually you would work with it and iterate and build something more complex, but this is its one-shot attempt at a more complex tower defense game. So, and then sort of to drive this home, so this is what, so I took an agent that's designed to create agents. I told the agent, make me an agent that's specialized in creating tower defense games, right? It asked me a few questions, I answered those questions, super similar to the Claude Code thing. Then I ran the agent that's specialized in creating tower defense games, told it create a tower defense game, that's all I told it, it built this in one shot. So this is, we have, sort of much more complex guys here, like pretty wide range of stuff. We can click on these, upgrade them for different things, sell the towers. The guys get more powerful over time, and so it's a pretty cool, like one shot, and so this is sort of my demo of this is how when you build an agent that's specialized to do a specific thing, and that's the only thing it cares about, all its attention is on that one thing, it becomes much more powerful in producing that thing. That applies to code, but doesn't just apply to code. It applies to other specialties as well. Oops. So, with that in mind, those things by themselves aren't ASI, won't become ASI, because there's no mechanism to improve or to go beyond a basic, yes, I can make one thing really good, but it won't continually learn or get better or create other things. So there's a couple other pieces that we need to add to this, right? So we have event-driven plugin architecture. So this is, again, fairly simple concept. So our tools are replaced with plugins. The plugins contain tools, resources, and event hooks. And so if you're familiar with MCP, this is fairly similar to MCP. And I mean, it's pretty straightforward. The only tools you fundamentally need are reading and writing files and executing terminal code. Everything else can be derived from that. But obviously, you'll add a lot more tools. And event hooks are events that happen within the agent that you can then intercept, modify, and then continue or cancel. That gives agents the individual power at the individual agent level and at the swarm level to monitor everything that's going on within the swarm and intervene or take actions. And then, the other ingredient that you need to create a fractal swarm is meta agents. So meta agents are the agents within a swarm that are specialized in maintaining the swarm and the agents within the swarm. And so these are sort of the meta agents that I've identified that would really be the critical ones necessary to create an ASI. This is entirely theoretical. I haven't done this, but this is sort of my theory on how you could potentially create ASI with an agent swarm. So you get the swarm manager, which manages the swarm. You have the creator, creates new agents, delegator, task comes into the swarm, which agent should get this task. Teacher monitors agent activity and improves it. Evaluator, evaluator is needed as part of the experimenter. So the experimenter says, hey, we want to improve this agent. Here's an idea on how we can improve it. We're going to run both of those in parallel. The evaluator compares the performance and chooses the one that does better, right? And you run that over and over, and that's how you improve individual agents with a swarm. And then you need a tool specialist who can, work on individual tools for individual agents or the swarm. And that tool specialist, we generally specialize it out into different types of tools. But the important thing about this is any of these processes can be run, like these meta agents are just agents themselves. Any of the processes can be run on the meta agents. So if you need a new type of meta agent, the creator creates a new type of meta agent. If you want your creator to become better, you use the experimenter and evaluator or the teacher to improve your creator agent, right? And so all of these little pieces, are sort of recursive and can improve themselves. The final piece that you need is that you need these to be truly fractal, right? So if you have a swarm and it contains a bunch of agents, what you can do is you can create a uniform interface between swarms and agents, right? And so that from an external perspective, swarms look like agents. And so I have a swarm and it has 5 agents within the swarm, but all 5 of those agents don't need to be like the final destination. Those 5 agents can be swarms that look like agents. But my swarm manager treats each individual one as it's an individual agent. And the individual agent, if it's a swarm, right, then it overrides the behavior and manages itself that way. And so, by doing it like that, the overall complexity of the system does not affect the local complexity of any individual swarm. So then you can, sort of infinitely scale, to arbitrary complexity. And so, yeah, so that's a quick overview, but I think that's it. That's my talk. Questions? Yeah.
How do you see the node management interaction once you designate a swarm and then you're interacting with individual agents?
So for any individual swarm, if we go back here, there is so part of the swarm interface or the swarm agent interface is the receive input. And so for example, if you get a chat bot, when you send a message, it goes to the receive input of that entity, right? And so the swarm handles it by passing it to the message delegator, whereas the individual agent will actually act on that message itself.
So it's a parsing.
100%. Yeah.
Are there any open source or proprietary frameworks that you can build swarms today?
That's a great question. Anybody know any? I mean, there are a handful that you can in a sort of way, but not exactly as I was describing. So, like in 8M, for example, you can sort of pass messages back and forth. Are there existing platforms that we can use to create swarms?
Create and orchestrate like the memory part of it and do. Yeah, for example, like I can build agents with ADKs right now, like there are plenty of them. Similar to that for swarms, are there yet anything available like that? No.
Yeah, there's Google's A2A, sort of, crap, what's that called? Not interface, but yeah, protocol. There you go. Thanks. Yeah, so that's a good layer to start with, but I'm not sure there's any like full frameworks yet. Hey.
So is swarm a industry term now, or is that something that you term for this?
So swarm is a fairly standard industry term, though it's on the newish side. So I did not coin that.
As opposed to Docker Swarm, I mean, people know when you say Swarm, it's a generative AI Swarm as opposed to.
You kind of, I guess it depends on context. Yeah. Like same as agent. Agent isn't necessarily AI, though most of the time you're referring to an AI agent these days. So.
I see orchestrator out there a lot. You know, you mentioned it.
Yeah, 100%.
Yeah. To manage the agents like Uber. Yeah.
Cool. Anything else? Hey.
Have you been able to, with forms that make it hard to inject it into anthropomorphized field, something that you normally have contact with, and you've been able to kind of generate this form onto any form currently?
Yeah. I've been doing it with so there's a chat bot, and you talk to one agent, and that agent then delegates to other agents. I've done that, but only within a coding perspective. So it's like talking to a project manager agent who has a back end and front end agent. That's a pretty rudimentary version of it, though.
Do you have any reinforcement learning?
And you pick out like what can we do to improve this agent. Sometimes it's tools, and sometimes it's individual instructions. So for the record, none of this, I would say none of it, most of that swarm stuff I haven't done on any sort of automated level. It's manually orchestrating it. So for example, like I have my own internal teacher agent that I will choose to run when I want to on another agent that's performing badly, right? But the idea is for this to all be automated in the future. Yeah.
But you haven't given these in hands yet. They don't have access to tweet or have you had it into the world other than living it inside itself?
A little bit. I haven't given it. I've given it access to pull things in, but not push things out.
Yeah. Have you heard about Hive yet?
I have not. What's
It's just next level of SRAM. So
okay?
it's a queen orchestrating the Hive. And
Gotcha.
SWAM, they talk to the
Gotcha.
some
Cool.
of them.
Yeah. Hey,
Why Fractal? Time commuting?
say again.
Why Fractal? Real time commuting? Like,
So it's. I mean, it's descriptive. That's it. So it's just. It's fractals because the swarm contains swarms, and it just infinitely goes down. Whereas when you're looking at from a high level, it doesn't. There's no complexity, right? It just all fits together. But as you dive in and look closer and closer, you see the more and more complexity deep within the tree. Any more? Hey.
In terms of, I'm just thinking out loud, completely like, maybe it's like, maybe a question for relevance or quality, but I'm just thinking that fractal method may be also good for security, something to compromise to like the whole system would not be, only pieces of it would be affected. I don't know. Like, I'm just thinking that, have you thought about that? How that could like also.
Yeah, that's interesting. I haven't thought from it that way, but it is interesting because each swarm would have its own little gateway where it could choose what messages to properly parse and not. So that is interesting. That's an interesting thought.
I'm just thinking like, let's say this, what you're doing in the project, like really, maybe you move in different directions, right? Different use cases.
Absolutely.
Maybe use, let's say, by a city to provide a service. And now, if something fails, you could still like, contain it. So the whole system is not affected. Right?
Yeah, no, 100%. And that's one of the beauties of it is like if something fails, right, we don't care. So if I'm a swarm, I tell an agent to do something and that agent fails, I can just decide to throw that agent out and create a new one that'll do it properly. And whether that agent is a swarm with 100 swarms underneath it or just a regular agent, I, as a swarm manager, don't care. Which is one of the neat things about it is it's like entirely adaptable, and you'll end up with like trees that are abandoned, and that's fine because the swarm as a whole gets better over time. I think like the security point. That's,
I mean, I don't
Yeah, pretty much. Hey.
Depending on where you go with this, you might want to take a look at composable.com without the trailing key, basically. But I believe I heard one of the founders' presentation, and they seem to have a pretty similar architecture as what you just described, kind of the orchestrator, the teaching, the learning of these specialized agents as well too. So,
Cool, yeah, that's awesome. I'll check that out.
technically, if you're trying to make some money.
Yeah, absolutely. Cool. All right, thanks. Oh, go ahead.
Might not be a relevant question, but just each added layer of swarms and the swarms, is there a way we can actually assess the value of these incremental complexity that we have to the final outcome?
I don't know. Good question. And that's actually part of the, that's one of the harder challenges is, I've played with it a bit, but one of the harder challenges is actually doing the evaluation of if I run this, did it run accurately? And even harder is if I run two bots in parallel, which one of them did it better? Especially if there's minor variances in between the two. So that's an interesting, hard challenge, to explore is how do you get an agent to, or an LLM in general, right, to accurately pick which is better of any given arbitrary thing. Cool.
I mean, I would pause. We can ask questions later.
Cool. Thanks, guys.
Thank you.
Yeah. Thank you. Mike, you can, Michael? Hi, yeah. Do you need HDMI? Okay.
Display synced, that's all.
Yeah.
So, all right, very good. Thank you. I'm Mike Rosmus. I'm an R&D consultant to startups. I helped them get organized in R&D. I helped them brainstorm, get some product roadmaps, and I also do some patents with them. But lately I've been working on LLMs. I'm going to show you some interesting, I think it's more computer science stuff rather than the application at the end. And I think you'll find it quite interesting, but it ends up with a practical measurement of the complexity of any kind of data that's embedded. So the semantic vectors that are embedded in LLMs represent the meaning of a bunch of input and how similar it is and what's similar to what. And there's mathematical ways to measure the complexity of that. So the term that's used by the mathematicians is intrinsic dimension. So I'm going to show you what it is and then how to measure it and why it might be useful to you. So here we go. That's Claude Sonnet 4 telling me what it is. And it's pretty good. I know more or less what it is. Basically, you're looking for the minimum number of parameters that are needed to describe the essential structure. That is the variation and similarity within the set. Okay? So, even if it's in a high-dimensional space, and believe me, everything that's in an LLM is in a very high-dimensional space, very high, and I'm going to show you that. So then it's like, how do we capture the idea that this data may actually be represented in its similarity by many, many fewer numbers? It's much simpler than those high-dimensional representations. And here's a really, this is a really intuitive example that I found. It's actually in the Wikipedia on nonlinear dimensionality reduction. So on the left, what you see is the A data set, okay? And we can quickly, as humans, say there's really only two variables there that matter: the scale of the A and the rotation of the A, okay? But those are 32 by 32 images, so they have 1,024 dimensions. And if we called it monochrome, it's 1,024 bytes, okay? So, but this being a relatively easy example, of course, but there is mathematics that say, well, let's map that and let's guess that it's two-dimensional. And of course, that example is an actual mapping to a two-dimensional space that shows that every one of those points has a a scale and a rotation. Okay? So you can see on the right that it's two-dimensional data, spots in a two-dimensional space. Okay? Not 1024. Now, to blow your mind, by the way, I'm going to get to Jupyter notebooks with real code pretty quick. This is what the LLMs do. That also is me asking Claude Sonnet 4 to sort of survey the world. First, I asked it what its own vectors were mapping into, and that's too secret, so it politely tells me no. Then it says, but here's some pretty good estimates of how the world is. Okay, and that's exactly what it said. Now, so what I wanted to do was, might as well go big. So I said, but what about the intrinsic dimension of all human knowledge? Which would be more or less, my guess is, that would be, what's the intrinsic dimension of big samples of the big embeddings in the middle of LLMs? Because LLMs are supposed to have learned pretty much every damn thing, right? And so far I haven't got Anthropic or OpenAI to give me statistical samples of their inside of their models. But if you go to Hugging Face, you'll find that two very credible data sets there can reasonably be called surrogates for a sample of all human knowledge. And there they are. Cohere a few years ago mapped 35 million plus Wikipedia paragraphs into 768 dimensional semantic vectors. And they gave it away. So you can download it. A company called Qdrant, probably never heard of them, but they used a well-regarded, completely different embedding model, Instructor XL, and they took 2,250,000 archive abstracts, the academic papers, across a wide swath of different, it's not concentrated in any one sector of academia. And so the third line is where you can find exactly what I'm going to show you in the Jupyter notebooks, okay? So all you have to do is look up J.M. Rosmus in GitHub, and there you go, okay? If you want to see this and get it for yourself. So that's me. Let's get rid of this. And then I want to do the Jupyter notebooks and show you that the world has gotten to the point where, let's see if I can drive my own stuff here. I want duplicate displays. That's perfect. That's exactly what I'm on. So I'm going to show you, I'm using Anaconda, which I'm sure a lot of you are familiar with. And I have my Jupyter's notebook server running. And what I have here is two Jupyter notebooks. One of them estimates the intrinsic dimension of the Wikipedia paragraphs, and the other one estimates the intrinsic dimension of the archive abstract stuff, okay? Now, what's really interesting and important here, I'm not going to have enough time to talk about all the deep mathematics, but it's really important to measure intrinsic dimension across the full range of closeness of meaning. That is, there could be a much richer, larger number of dimensions for things that are close together, lots of different ways you could go, or looking at things that are much further apart. They may only have a few dimensional directions that they can be different. So what I believe is the right way to do this measurement is to do a loop that measures the intrinsic dimension as you go further and further from each sample, okay? Now, the other thing I want to emphasize here is if you're not using Claude 4 Sonnet to write code for you, try it. It's really good. Now, I wrote very little of this code. Most of the time I'm a consultant writing papers, doing research, and helping. So I just jumped in here and I said, I want to do this. I want to see what this is. And here it is. So this first part, this is a Jupyter notebook. The first cell, as you can see, is very simple. It just downloads the data set from the Hugging Face. If you've used it, you know that Hugging Face has a really nice data structure. It's a data set data structure that's set up to hook right into a big neural net model. So all I do is use its own stuff, get the data sets, import the data set. Now, easy to download, but you better have a robust computer, especially if you're doing 35 million samples from the Wikipedia. So this is done on this computer. It's a solid computer, about a year old, $1,500 laptop, and 32 gigabytes of memory, and it gets there. Okay, and I'll show you what the limits were, but it's easy to blow it up too. So get the data, download it. Every one of these pieces, every one of these cells in here, I just told in good descriptive solid computer science language, I told Claude Sonnet what I wanted it to do and what the previous cell was giving it, and it gave it to me. I mean, I was impressed, and I highly recommend. So here, I told it to convert the vectors from the data set. That is one of the fields that has the actual 768 floating point numbers. I want it to turn it into NumPy arrays, and it does it. In this case, there's 2.25 million of them, and I tell it how much memory I've got, and it's smart enough to break it down into chunks, keep the memory from going crazy, and it worked it out for me. And all I had to do was read it and go, yeah, that's interesting, and I even learned from it, obviously, because I said, what's that doing? And it just tells me. And down here, the result is there's the 2.25 million. It divided it into three chunks, and it ends up processing it, and it turns it into 3 .npi files, which are the files that store NumPy arrays. There you go. Took a little while, 400 seconds. Now I say to it, I want to do random sampling of those things, because I'm not going to compute the intrinsic dimension requires that you look at the differences, a distance matrix of all the samples that you use. So you can't put million by millions in there, but you can tell it to randomly sample and then get as many samples as you can. So have it randomly sample. In this case, I told it 1% sample, and it uses what's called a reservoir algorithm, and it taught me. And a reservoir algorithm very efficiently samples up to the size of how many samples you want and checks to see if it's sampling the same thing again. It will, like a reservoir, it'll take one, it'll sample randoms, but never two of the same thing, okay? And it's very efficient in memory. And I looked at it and go, okay, that's great how that learns. You can see it processes each of the files. It does the million vectors, the 2 million vectors, and then the third file that has the 250,000. Now, I say estimate the intrinsic dimension by correlation dimension. The correlation dimension method, I'm not going to do all the math, but I'll sit down with anybody afterwards. It's pretty intuitive. But it looks at how fast the number of neighbors increases when you move further and further from each point. So it's looking at the complexity and the number of dimensions as you scale around each point. Now, interesting thing here, it's free. A few years ago, some smart guys in Europe, led by a Belgian named Jonathan Bach, wrote the SKDIM package right here. And it has multiple ways of measuring intrinsic dimension. And I'm going to suggest to you that it's a technique and a measurement that's underused. But a few years ago, and there are some now academics measuring it, and I think it's going to be very useful, and I'll show you why. So what I did here is I said, I want to know the intrinsic dimension, and here I say, first I want to know close-in intrinsic dimension. That is 1% of the samples to 2% of the samples from each sample. And then 2% to 3%, 3% to 4%. Now, what's really remarkable here, the way this works, it looks at every point, and it looks at what's near it as you grow the range around each point. This is, I think, very mind-blowing, and that is this gargantuan set has a very, very distinct pattern in intrinsic dimension. Very distinct. So close in, there's dimension in the 1718 neighborhood. Now this is 1% to 2%, that first point. And then it shows a lot of complexity or a lot of directions in which you can have similarity, and then it gradually decreases further out, which makes good intuitive sense, right? There's more ways that things that are very similar can be slightly different, even distinctively so, for each point that's close, okay? Now, I also did, okay, what about real fine? This number looks like it's getting pretty high in here. So I also did, never mind that I did derivative just because I was interested. But let's look at, this is close up. Now, to me, it's very remarkable that even very close up, this is 1,000th sampling, which is like 22 samples out of the 22 of the 2.25 million, okay? It only has 20 dimensions or so. Now, that means that these LLMs, which are doing 1,000 to 10,000 plus dimensions, are way overspecified if this math is correct. And it's pretty well established kind of stuff. Now, but to blow your mind a little further, I did the same exact thing with the 35 million Wikipedia paragraphs. All the code's the same. Got same code that Claude wrote for me. What's really remarkable here is that the shape and the amounts almost the same. That is, completely different surrogate set to represent human knowledge, completely different embedding algorithm, but the intrinsic dimensions very, very close to the same. So I'm suggesting that lots of human knowledge, and let's do it, let's look at the close-in. Even when you zoom in, look at that. So, no more than 20, maybe a little bit more. You zoom in a little closer for very fine differences in very close semantic bits of knowledge, whatever kind of chunking you're doing. Now, that strongly suggests you can go to my spot and take this code. I think it's intriguing from a computer science point of view. Like, this is maybe a pattern that's very reliable in human knowledge altogether. But as a practical tool, if you have been building, for example, some kind of a neural network that's mapping images into some kind of meaning space, and you're looking at similarity, how many dimensions do you need, right? You can run all those sets for whatever you've got now. And you can even run them through the front end of a VLM, and you get these great big giant vectors, like Cohere, for example. And then you can run them through this, and you can say, okay, but I need this thing to run in real time, and it's going to be hard to do that with 1,000 dimensional vectors when I'm comparing to see what classification this image is in. Find out what you're aiming for. You can run this and it'll tell you, hey, we should be able to do this with 30 dimensional vectors. That doesn't mean that it gives you the map or the algorithm yet to get there, but it will tell you what the theoretical complexity is. Okay, so there you go. 1, 2, 3, and I think it's pretty. And you saw that code. It's like, oh, how can it be this simple? Well, I think the time just came. You know, like they gave me the LLMs are giving me the giant sets that represent the knowledge, and I kind of piece things together. Okay, questions, comments? Yeah.
So, if you like really like this is fascinating. Why do you think they're going bigger and bigger the dimensionality of the numbers?
Well, because they can, right? Think about it. I've read this. I'm not an expert in it, but people do some work with 1,000-dimensional vectors in the core, and then they say, well, let's just experimentally, let's just see if it works better with 4,000. And oh, yeah, it's better with 4,000. But I think you're getting a diminishing return, right? And I think we need theoretical improvements, right? That is, we need way now. I'll do a step further to help you. There's a paper about 2 years old, and there's a team in an Italian university that's measuring the intrinsic dimension of each layer of various kinds of of neural nets, including ImageNet. They did it in ImageNet, and they're finding roughly the same range. As far as I know, they didn't try what I tried in terms of let's see what all of human knowledge looks like, but they were seeing 25 to 35 dimensions in the layers, the information in the layers of ImageNet near the end of it, right? So they were basically concluding that dozens of dimensions is enough to differentiate the images, and ImageNet is doing it. They're demonstrating that's happening.
Yeah, ImageNet has 1,000 classes. It's not human knowledge.
Right.
I mean, in image or like multimodal data, we are not even close to capturing human knowledge like we have in Wikipedia.
Okay, well, that's why, I mean, obviously, I don't have all of human knowledge in any data set, but I'm making certain assumptions, right? I'm making certain assumptions that bottom line, human beings encode human knowledge in words. We write technical papers. We do the abstracts that describe what's in there, okay? And I'm taking that as a surrogate for quote unquote all human knowledge. But I'm saying that I think this strongly supports the notion that we're thinking and writing down our knowledge, whatever it is, in a 20, 30 dimensional space, more or less. So, comments, questions? Yeah.
I have a few comments. I've worked a little bit on vector quantization with classical machine learning.
Yeah.
I have some work in India. And to the best of my understanding, the way it differentiates, the way it's vector embedding is differentiated within large language models is that they're not on orthogonal but on near orthogonal basis,
Mm-hmm.
which sets somewhat of a differentiation when you bring down the dimensionality from 8,000 to 9,000 down to 20, the near orthogonality loses its property.
I see your point, and I think, I don't know, I don't have an answer, of course, but I think there does seem to be a consensus that if you're doing anything with textual vectors, which I am, and most of the LMs are, that cosine similarity is the way to compare them. And the suggestion I saw was that how big the text patch is actually changes the length of the vector, okay? So I'm not sure what orthogonality would mean in that sense, but I do think that the directional kind of thinking makes sense. And I do have in mind some further experiments to see if I can actually map some stuff into lower dimensions, right? And in all those experiments, it looks like I should be using cosine similarity, which is that kind of thinking that you're talking about. But I can't say anything about what does the concept of orthogonality mean in a 20 or 20, 30 dimensional space. I'm not sure. Okay. Yeah. Any other comments? Great, thank you. Feel free, like I said, MIT license, just say, Mike gave it to me. Try it on any data set. There you go. Thank you.
Thank you. Robert? Yeah. Do you need a dongle?
Hello. Yeah, welcome everyone. My name is Roberto. A quick intro about myself. I run a meetup here called the React ATX. Upstairs on the 16th floor, we're having an event next week. If you're interested about learning about MCP server, and of course, everyone here already is an expert in agents. I'm doing a full stack survey for front-end developers engaging in MCP servers, right? What does that entail? Anyways, just want to give a shout out there. I've been in Austin for about a decade. Prior to that, I was in Boston. Dating myself, I used to work at a Circle Internet Financial Bitcoin company back in 2014 before they blew up, and now I guess they IPO this year. Anyways, Bitcoin has been part of my career for a very long time. I am a full stack developer. I have a consultancy. I've been doing consultancy work for about 6 years now. What I want to introduce to you today is kind of like my experiences with consultancies and working in over a dozen companies, and the patterns that I found as a developer that would help me kind of like accelerate, I guess, productivity. And so I have I'm doing a startup. It's called Synapto. Tagline is mechanized data APIs. Just quick hands. Anyone here developers, like actual application developers, not MLL engineers type of things, right? Yeah, a few, not very many. And so I think back in 2018, I was working, I think it was Expedia at that time, I forget where, but I was introduced to Kubernetes, and as a application developer, kind of full stack developer, I was just amazed of the abstraction that it has done, that Kubernetes brought in the kind of like the productivity boost, and the fact that I don't have to learn about Linux servers, I don't have to learn about distributed systems and all that stuff. Kubernetes just gave you like a chart or a configuration. You configure it, you learn about it, and you deploy it, right? You execute it, and before your eyes, you have a 3-node cluster scattered around the regions of the United States. And I kind of just fell in love with the idea of this pattern, right? And as an app developer, I didn't have to write any code. I didn't have to learn Go. I didn't have to learn about etcd. I didn't have to learn about a bunch of the stuff that goes into making Kubernetes, right? And so that's kind of stuck with me as an experience as an app developer. Got my certificates in there and went full-blown DevOps mode kind of app. And so the companies that I used to work for were migrating into a Kubernetes structure. And so a lot of the patterns that I learned during that process is kind of like a manifestation of what Synapto is, what I want Synapto to be. And so for the most part, as an app developer, one of the very common problem that I was introduced to or hired to do was what I call like data APIs, which is basically, hey, we have a microservice, we've got a back-end service, we need to expose some APIs for our front-end clients or some other consumer or some other microservices. We're going to bring you on board, you're going to write these APIs, you're going to connect to an S3 bucket, you're going to connect to Postgres, you're going to connect to Mongo, you're going to connect to MySQL, whatever the data integration is, right? And put it in a Docker container, and help us deploy it. And so that was a very common pattern. And as doing these development works, and going to a bunch of meetings, and bike shedding. What framework we're going to use? We'll use Express. No, let's go use Fastify. No, let's do the Ruby thing. No, let's do the Rust has came out, right? Rust has a new async, and then you're like, okay, cool. How about validation? Okay, we have to validate. Okay, what kind of library you want to validate it with? Oh, you know what? Let's do ORMs. Okay, what kind of ORMs drivers do you want to use, right? And on and on and on. It's like, oh wait, we forgot to bring in the front end devs. Oh great, so we're gonna bring in the front end devs, right? All to like spec out an API. So a lot of time wasted, a lot of good money, a lot of great experiences, but as a developer for myself, just very boring. Especially when you're done with the meetings and you're sitting in front of your laptop and you're coding what you love to do, it's the same thing that you just did the last 3 companies, right? Or the last 4 companies. And it's just like, okay, an API. Does the business really care if the API is written in Rust or in Go or Node or in Python? Does the consumer? No, they don't really care. They don't even have any idea of what a server is. Does the business care that you use Prism or ORM or Next ORM or whatever ORM, Action ORM, or if you're following the best OO patterns and stuff like that? No, right? That's not the value. The value is the data extraction, the data integration, pumping that data to an API to be consumed. And so Synapto is a manifestation of that abstraction, where I took the learnings of like Kubernetes and these higher level containerization, right? No one's writing new container software, right? We just use what's already out there. We just use Kubernetes. We just use these other open source systems that have been proven to be the right abstraction layer. And so I'm trying to tackle the back-end abstraction layer, the API abstraction layer, where we don't have to think about writing code anymore, right? I don't have to think about distributed systems anymore. I just write the value, which is a spec of an API, a JSON schema, maybe open API spec. And what are you going to do with that? You're going to integrate with some data, right? Postgres data, Mongo data. Okay, great. What's the value there? It's the query. It's the data that you're pulling out. You're going to pump that data that you're pulling out from the query and shove it into an API, right? It doesn't matter what language you use. And so Synapto is kind of like working on that abstraction layer where you only set your mind and focus on I guess, the business value. What is the value here that's going to be done? Anyway, a lot of words and a lot of abstractions, but what I wanted to show is twofold. One is thinking from an app developer perspective, right? I think the role of developers in general is obviously changing again with AI, but I do not think the future is generating more code. I think it's great for vibe coding, but you're not going to vibe code a new Kubernetes. You're not going to vibe code a new Vercel. You're not going to vibe code a new containerization or a firecracker, right? You're not going to vibe code that. That's already established. Where you're going to be vibe coding is at the very top of the abstraction layer. They can throw away, build and throw away really rather quickly. And so without further ado, I'm just going to walk through like a kind of like a demo of what Synapto offers relatively quick. If you're a front-end developer working with React or any of the front-end developers tools, right? We all know about hot reloading and how cool it is, or how of a game changer it was when it came out with Webpack. And then also the deployments, right? One-click deploy coming from the DevOps world. That's just like mind-blowing when you can do something with Vercel and just deploys everything, and it gives you automatic, analytics, monitoring, and all this other crazy stuff, right? Anyway, so Synapto is on the data API side, on the API side. Let's say that as an API developer, right, there are a few things you're going to use an API for, right? One is to like mock an endpoint after your meetings and everything. After your bike shedding, you're going to mock an API point for your consumer. Here we have different response modes of an API. You have echo, right, stubs, mocking, and then I have this, I guess, new response mode I call query response mode. I'll get to that soon. The idea is like, hey, we all know what OpenAPI spec looks like, right? A Swagger doc. It mocks out all of our documentation. Most likely it's not up to date, right? But we all kind of seen this developer tool. And that's one other thing too that Synapto does is combines two developer tools into one plane, an API client and a data client. And so this is like the look and feel of a Postman, if you know Postman, or any other API client. All API clients look the same and feel the same. And it's a tool that's very common in our industry as app developers to mock or even test API endpoints. The thing is with Postman and all the other API endpoints is that your back-end team has to build the API, right? Before you put it inside Postman, someone has to go out and build it, and then you integrate it, or you use Postman as a contractor, right, as a contract between it. What Synapto does immediately is as soon as you describe or design your API, you save it, it builds the server in the back end, and you're off to the races, right? This simple presentations API, they're all echoes. And so what Synapto literally just did is create a server and built and inserted these APIs into that server, so that as soon as you save it and you hit send, just like an API client, right, you get that the liveliness of that server. Now I'm going to mock that endpoint. I'm going to go ahead and save it, so I have to build it again and send, and then I'm just going to interact with it as an API client. And so it's smart enough, the server is smart enough, or Synapto is smart enough to know that you're mocking it, and so that it's mock data. So yeah, you get the look and feel of real data coming from your contract. Obviously, in a kind of like in a API client or any API, you have to have response modes or responses, right, with the status codes and all that stuff. But the gist here is that every API, again, regardless of what language you're using, can be kind of modeled off of a JSON schema. And so the foundation is, as long as you know their JSON schema, right, you'll be able to, Synapto will be able to take that information and generate the responses based off of that. And so this is where the AI kind of kicks in. The assistance of the AI when you're building these type of things is like, hey, I don't know JSON schema. I don't even know what APIs are, right? Maybe you're in a meeting and the project manager has to bring in a team of front-end developers, a back-end developer to help a client with their API issues. And so I have these quick texts. So let's say you have a payload and you need to generate an API, right? And it's like, hey, I need a JSON schema, for this data, right? And so the AI immediately generates that JSON schema. You can copy and paste it into your response modes, and you're off to the races, right? You immediately can have that JSON schema inserted into this like response body, and Synapto knows what you're talking about and generates that server in the back end, and you're done, right? No more work to be done. And so it kind of takes care of all that bike shedding all away, and really just makes you focus on the product, right? The value of the whatever it is, the business value. Now, I want to integrate a data source to the speakers, right? I have a Postgres data or whatever, and I already have tables, and I already have data associated with it. I want the AI to figure all that information out. And so in the back end, there's an API MCP server and a Postgres MCP server. And we can come here to the AI, and we can start asking the Postgres assistant questions about the database that's connected to it. Now, just to drive the point home is that on the right-hand side is like your typical database client, right? Think pgadmin, database beaver, or even extensions in VS Code, right? You're gonna write some SQL. Here's Postgres, but you can think about it like in Mongo, you're right, like something like MQL. Or if you try to connect to Splunk, right? You just write the Splunk query. You're trying to pull data out, right? The query is the query is the goal here. And so I'm just gonna I already have a query here. I named it select speakers and so on and so forth. But I want to generate, if you don't know like SQL, right, which a lot of developers don't, they don't like it, whatever, you can ask the AI to generate a SQL that returns that property of the JSON schema. Again, JSON schema, right? You can transfer the JSON schema, ask the AI to like, hey, I only have a JSON schema, but write me a SQL query that is associated with that, right? That returns that JSON schema. And so the AI writes it, whatever, you copy and paste it and you run it. And so it's already attached. So I just attached the query to the response. I'm going to change the response modes to a query. And it tells Synapto that you want to actually create a full-blown end-to-end data integrated API without touching any code. And so this is actually hits the database and returns the data in the same format of the JSON schema, right? And so imagine all the tests auto-generated, all the validation is already there, right? And you have a hot API. You go to the specs, the documentation is automatically generated for every time you change stuff. And so in the query, right, response mode, I just generated the spec for the speaker that I've been messing around with. And so, and then again, deployment, right? Once everything is done and set up, you just hit deploy and you're done. In the background, the AI is just orchestrating the agents to do work. The code necessary for that work is already written, right? So the agent there's no code gen at all, right? That's why it feels very instantaneously, because it's already written, right? All the infrastructure, all the pipelines being connected to each other is already done, kind of like similar with like Kubernetes, right? Or with like any of the other abstracted higher level systems. This system built for data and APIs the infrastructure is already built for you. All you have to do is send it the parameters that you want, which is the API signature and the query that you want to integrate with your data to extract it and pump it to your API. And so the deployment takes about less than a minute because it's on Vercel. It's kind of slow, but we're building it out so that we're using Envoy. They have like hot reloading, and so it should literally take about 2 seconds, like a second or 2 seconds to actually deploy your APIs out. And so and if you think about it, so that's kind of like the idea behind Synapto. It's like this very abstracted layer where underneath it, we call it like AI empowerment. AI is doing a lot of work in the background, but you don't see it, and you're not supposed to see it. You only see a very, very abstracted face of AI. And that AI is just there to, like, empower you to do stuff that you don't want to do by hand, like auto-generate code. Auto-generate mock data, right? Or write very complex SQL queries. And so the AI assistant is there to help you do those business stuff. In the background, think about it, it's connected to all these agents that are actually doing the work to return this data API, which we call a data API. And so part of this, and the next thing I want to show real quick is thinking about as a developer, as an app developer, thinking about like the interfaces. Like, hey, if writing code is not going to be, the top priority, just like spinning up nodes isn't a top priority anymore, right? When you have already these abstraction layers, when you already have AWSs and infrastructure already built out, it's kind of thinking and dreaming about like what's the role. And so I think the DevOps role is actually it's going to meld into a kind of an operator role where you as a developer, you become an operator. An operator of what? And so another thing that I've been working on is trying to envision like, okay, if I'm an operator, I need to be in charge of or whatever operating my business applications and things like that, right? And so one of the things that myself and I'm working with an intern right now is trying to imagine how an operator workspace will look like, how you interact with it, why would you interact with it, what's going on in the background with it, and most importantly, what's the business value to use something like this as an operator. And so this is connected to the Postgres, but you can see like every column here on left and right, they're MCPs or agents, right? And they're going to trigger other MCPs and tools and all that stuff in the background. And you want to kind of like get a world view of what's going on in your application. Again, no one's going to write any code, right? All the integrations are already in place because that's all automated away from you. The security, right? Best practices, enterprise ready, enterprise grade, observability, all that stuff, right? The entry point, I don't like it very much to the point of like everything's a chat box. But again, just trying to drive the idea home that maybe in the near future, we're not necessarily just writing code. Maybe code is 20% of the job of the AI, but mostly trying to extract knowledge of what our systems are doing, what our customers want, make sure our uptime, database management, all that good stuff. And most importantly, manage our clouds. in a sense, like any front-end developer or even product manager or anybody off the streets can set up a system like this, and they automatically get access to everything associated with, you know, their demo product through AI assistance and stuff like that. But yeah, that's the kind of two things that I've been working on the last couple of months. Any questions, comments? Yeah.
Yeah, I have a question. So this is again really fascinating.
Cool.
I have a question regarding, okay, yeah, we are running away from code, but what happens when the systems grow in complexity and there are like these weird bugs that really need someone who kind of like knows the code internally, spend a lot of time with these systems, and only then, like right now, AI is not at that level to actually go and debug these gnarly like bugs, right? What is your take on that?
So, I mean, the short answer is I don't know. I think what I tell people about when they ask me this, and I mean, what happens when Kubernetes throws a random effing code, like right, or some other online service that does some kind of abstraction, and the thing is you report the issue, right? There's not going to be a stack trace that you can debug it yourself. At this point, you're kind of like you're bending over the abstraction, and it's kind of like promise theory. The thing Kubernetes promised you that, hey, if you give me this configuration, I promise to adhere to it, right? Declarative, whatever you call it, right? In the same way, this is yes.
I think it's sort of on top of this question. I have two comments, and they both have to do with the fact that I think the state of the art of AI doing software development at all levels is moving super fast. And Claude Code, which was mentioned by one of the earlier speakers, claims a feature, and I have talked to a much younger developer than me, a leader of engineers who's got like a team of 12, and it goes right to your point that you asked about. You can tell it, go learn this repository, learn how all the things are connected, and I want you to modify it in the front end, the feature has to change such and such, and it will actually give you a recommendation for changing all the files in the file. And I know people are actually using it. Now, on top of it, you asked about bugs. I mean, even at my personal level, I did some stuff that I got some bad error messages coming out, and I thought, oh damn, I'm going to need to add the debugger to my controller lab. No, I just said this is what the error message is saying, Claude. What are the causes of that sort of thing? He gave me a list of 4 or 5, and I said, well, fix that one. Now, that was a small scale, but I'm talking about large scale, small scale. Claude Code's $100 a month. My Claude Pro is $20 a month. I'm going to suggest you may have a risk, which has to do with, that has happened before, you're not seeing almost the whole history of computer science. You know, the big guys seeing good ideas and absorbing it into the fundamentals. So I'm suggesting that the AI is made easily, you know, Anthropic, Claude, or OpenAI, ChatGPT, may start absorbing the ability to do what you're developing faster than you can finish. That's a risk, right?
Yeah. Oh yeah. Yeah. Oh, one question I get is like, what's preventing AWS from doing it, right?
So monitor, I'm just going to suggest monitor the best Claude Code can do to see if it's like you're forcing you to higher level. Doesn't mean you've done right. You got to just say, I got to operate a layer up because it just does that now. That's all.
Yeah. So, but the thing is not though that you don't ever see code, right? Just like when you run Kubernetes, you don't ever see code.
Yeah, but I think Aki's question is true.
What?
Something will go wrong sooner or later.
Yeah.
And then
Right.
it's like somebody's got to look at the code and it has to be I'm saying it could be a knowledgeable person with Claude as its assistant. That's all.
Again, I tend to agree with that. Maybe in the future, AI will actually be at that level as a principal engineer or someone who actually can debug these underlying bugs, or
Yeah.
underlying bugs which are kind of scary to actually debug. Yeah, but right now we are not at the stage. I feel like we still need human in the loop.
Yeah. The empowerment. You still yeah. So it's not AI driven. Absolutely not. And you don't even have to use AI for any of this stuff. And if you are a user of this platform, you never interact with code. There's no code gen. You never see code, right? It's if you ever want to host it yourself, you see a container, and then you can do whatever you want to do with that container. But again, that code and all that stuff, you don't have to see it. You don't have to touch it, right? Just like if you download any other Postgres containers, you don't have to see the C++, whatever it's written in, right? And so if there are errors, it is Synopto errors, right? And you copy and paste it, and you ask the AI, hey, Synopto's giving me this error, what can I do? And hopefully I have documentation for that. If not, you just got to go to GitHub and open an issue so I can fix it, right? That's kind of like the process that I have set up right now. But it is one of those things where, I mean, the reason why this is taking so long to do it because it is a developer tool. And if a developer tool starts backstabbing you or throwing you off loops, that destroys the trust, and you're not going to use it, right? And so there's a lot of guardrails and validation involved to make sure the LLM, if you do use it, is not going to generate something that you deploy it and it, slams your business value, right? Yeah. So I'm using any model out there, whatever I can get. I don't train my own stuff or anything like that, right? I'm building on top of whatever's out there. So Claude and OpenAI are the main ones that I use. Gemini as well I use. MCP, obviously the TypeScript SDK, the open source version. Yeah, a lot of Postgres.
Any best sort of common question? Any best practices you can share, like maybe if you are trying to instill for yourself and for people around you? It's saying like if you don't use it, you lose it. Like people are becoming more and more dependent on AI, and I think that's going to increase in the future. How do you ensure that today there's people who are able to debug and check me, but maybe in the future there's going to be people who are so dependent that forget they won't be able to similar to math problems. Many people can do a math problem on paper, they apply a calculator. Right. So any best practices to really make sure that you're still thinking of things being able to do it independently, not just reliant on AI, so that you don't maybe lose some of the abilities that you work so hard to develop and something like that.
Yeah, that's a really good question. And so I've been running that meetup for almost 10 years as well. And so prior to AI, right, there's a lot of boot campers that come through who learn very abstracted frameworks and don't know the fundamentals at all. And we're just talking about fundamentals of HTML, CSS, and JavaScript. They go 100% on in their boot camp, and they learn, I don't know, some kind of Angular framework or Ruby on Rails framework. And so they have a very hard time trying to debug browser stuff. And so I think that problem has always been, is just now it's super easy, it's easier to build these things without any type of fundamental knowledge. I think to add to that as well, I worked at a startup where it was a big team, eight people team, and the CTO was very hands-on coding, but he wasn't a good coder. And I remember what he said. He's like, I'm not good, but I'm good to be dangerous. And he said that as a positive thing. And what I got out from that is like, do not let this guy touch code. He can write code, he can do a lot of stuff with code, but it's very dangerous what he's doing because he's gonna break something, he doesn't document anything. It's like it was very cheaply done. And so I say that because the short answer is like, I have no idea. I've been doing this for 10 years and people still come to me and they learn these framework abstractions and they, break down when they come across like a CSS rule. And it's just like, it's very easy to Google it, right? I'm sure Stack Overflow already solved this problem 10 times, but for some reason, they just run into that problem and they can't figure it out, right? So that tells me they don't have the problem solving skills. They're not in it to become professionals. They're not in it to be an expert developer. They're in it just, I don't know, to make money. I don't really know. And so now, I mean, vibe coding is super cool. I do it all the time. There's so many tools out there like Lovable, like V0. I learned about Figma, right? And you can get so many things done, and it's great for startups. And it's awesome for startups because you don't know what's going to work, and if it's a shit product, well, good thing you didn't spend, $10,000 hiring a full stack developer that took, 12 months to build it out for you, right? So the churn is real, and it's like great, but it really depends on like what I like mentor developers. Like, what do you want? What do you want to become? Like, are you going to go 100%? I run React Meetup, right? React, and that's it. That's all you want to do is front-end development. It's like, yeah, I want to do that. Okay, then you have to learn CSS. Like, you can't just learn Tailwind. You just can't ask AI to just do the Tailwind for you, because do you also plan to work at a company for 10 years? No, most likely not, right? You're going to just jump ship after 2 or 3 years, and then when you go to the next company, guess what? They don't use Tailwind. They use something else. Now what? Now you're stuck. Now you have to relearn all, like whatever stack it is, right? And so the fundamentals is like it's constant. You learn the fundamentals of CSS, HTML, CSS, or whatever, right? You know the fundamentals of Kubernetes. I mean, reasons why Kubernetes came out is because every Snowflake company was doing their own thing. It was terrible jumping ship to relearn a whole development pipeline, right? And how to manage distributed systems. And so I kind of pluck them out, developers who are really curious to learn to become these to learn the fundamentals. You can identify them, right? They're the ones that don't say stuff like, "Oh, I just vibe code it," or "Hey, I'll just use Tailwind to do this for me," or "I don't want to learn CSS; it's too hard for me," right? Like, you're software. You're gonna be doing this for your career, and you don't want to learn CSS, for example, right? It's like what do you like? Okay. The thing is, our market is, I like to say, irrational, right? I have no idea why people get hired with that lack of certain skills, but I know businesses just need to crank out products and services. Like, does it really matter if you code it in JavaScript or in Ruby on Rails or Python? Probably not. The business doesn't matter. It just, can you do it? Yes. Deliver it in 2 weeks. Great. Do it. If not, then I'll go to another candidate who can tell me they will do it. If they actually do it, it's a different story. But they convince me they can do it, right? I don't know. It's really, really daunting and confusing. I think being a brand new developer now is really confusing. If you're a senior developer, I think it's really great. Like, as a product manager with a lot of experience, you have all these ideas in your head. Now you can see them come to life within hours, instead of spending years trying to build something, or learning APIs, or learning Postgres, right? Long-winded answer.
I think we have one last speaker, Rajesh.
It's dark or light better. Okay. I think this should have been a pretext to like Curtis and Roberto's sessions, because they talk a lot. I mean, they spoke a lot about agentic AI. So this, I'm just trying to cover the difference between AI agents and agentic AI. So I believe like most of you know what it is already. I'll just skim through, or for the benefit of the large, I'll just go over it. I would like to start with an example, and there is a paper on this, like a difference between AI agents and agentic AI. I'll just borrow one of the example from that. In simple terms, you have smart thermostats at your home, right? So you have temperature, it monitors the temperature, and you can set a schedule for it. That is something like AI agent. So it has a narrow scope, what it needs to do, and it has a defined set of rules, what it should follow, and it really does not go and do anything with your home, or it does not check anything else. Now consider a smart home, where you have sensors all over your garden, your room, and your garage and stuff. And then you also have a smart thermostat which talks to all these sensors, and based on that information, it turns on your water on your garden, it sets your temperature, it senses whether you are at home or not. Based on that, it tunes the temperature, and also like your comfort level, right? So it interacts with multiple systems, and each of those systems are also smart, but have a narrow scope. And then there is one master agent that actually decides what needs to happen, right? So that's pretty much what I'm going to tell on the next slide. So to make it more interesting, so we also spoke about Claude Code now, right? So let's do this. This is Claude Code, if it is large enough. So let's try to build an application as we go on this session. So I have opened a Claude Code session, and I'm saying build a survey application with elegant and competent UI, just to give more context, to survey 5 speakers on a technology event that is this. And I'm asking to use a SQLite database, which is easy, not for production use. And I'm just giving AI tinkerers, and I'm giving it a challenge to search web and find a logo. Let's see if it does, not sure. And I'm asking you to use a test-driven development approach. What it does is it actually writes the code, it runs it, it tests it. If it fails, it goes, corrects it, it runs it again, and it keeps doing this loop until it finds that the code is working. And then I'm just giving some more instruction, like you use UV run so that it uses the environment so that we are not getting any environmental issue. Let's see what it does. Okay, so let that be running on the background. Let's get back to the presentation. About me, I'm Rajesh. So if your workforce or the workforce in your company you're working, like in the fast-moving AI world, if you feel like you're missing out, and if you want your workforce to fit into the AI race, like hit me up on my LinkedIn. We help people like choose the right tools for your business. Like we learn what's your business and what are the right tools that will help you, and then train your workforce to excel the tool. Like just tool doesn't give you anything. Using it right is what is giving you the real result. I'm a founder of Onboard AI, and I started this aiming at AI education, and I'm partnering with another startup, which is going to help the US education system, where you all know about a press release that came out on AI education for K-12 education. So this is aimed at that. Focus AI, I'm running a synthetic AI podcast where it's completely no human. It's AI, like there will be 2 hosts, they'll discuss on a topic. And then I'm a founding member at Agentics Foundation. This foundation, we do all kinds of research with Agentics stuff, and we try something, if it doesn't work out, scrap it, and then try again. That's all we do. And I'm also an independent consultant. And this is the QR code for the synthetic podcast. Okay, so starting, let's see how AI agent became agentic AI, or how agentic AI is born. So first we all started with generative AI back in 2022 when ChatGPT was released. It was not impressive, but it was magical, right? So let's fit that into generative AI. So what it does is we have a model with weights, right? Weight is basically what it does when you give a user query. It runs probabilistic weights, and whichever is closer, that's the result it gives as an output. For example, cat sat on the mat, cat sat on the wall, cat sat on the moon is very rare. It is not on the training data. So the probability is very low. So if you say cat sat on the dash, it's going to give either mat or wall based on the training data. If the training data had a lot of mat, then it's going to give you mat. If it had a lot of wall, it's going to give you wall. But moon, hypothetically, it doesn't. What happens if there is no mat or wall? The cat sat on nothing. Then it might hallucinate to give you anything it likes. It might give moon at that time. So that's hallucination, very in simple terms. That's generative AI. And one more thing to add on generative AI is like, LLMs are stateless. What I mean stateless is, every time you ask a question to a large language model, the entire history and whatever system prompt and whatever instructions you have given, it goes to the LLM. LLM goes through it, gives you a response, and then forgets about it. Then you might have a question like, then how in ChatGPT and Perplexity and those kind of stuff, it remembers the conversation, right? Somewhere in the history you would have told your name or your favorite pet is Labradoodle. And down the line, if you ask, I want to buy a pet food, tell me a brand, it's going to give you a food that Labradoodle likes and not a cat food, right? So how does that remember is where AI agents come into picture. So AI agents are like I would call more a deterministic system that wraps around a large language model that helps to remember what a user's conversation was, what is the context, and there is something called a system prompt that you instruct the large language model on how to behave. So that's an AI agent. And if you compare with the example that I told you early on, it has a narrow scope. It cannot invent anything by itself. Like whatever it has been scoped to do, that's all it's going to do. And in today's world, like what AI agents are, ChatGPT, custom GPTs, it can it can remember certain set of instructions, it can search the web, it can read through your files. And again, the scope is so narrow, right? It doesn't do anything by itself. And then slowly we evolved into tool support. So tool support is what I call web search, your file, and now if you look at Claude, it can integrate to your GitHub, and it can read images, so it can also blend with another multimodal models and then give you output based on that. That's tool support. And React loop. So if you see, we are slowly moving from AI agents to agentic AI. So what is React loop is reasoning and act based on the reasoning. And of course, you all should be aware of the reasoning models that came out, right? 4.0 and so many reasoning models. So when you give a question, right, a user query, it reasons like what is the user is trying to ask. It breaks down the query into multiple steps. And then probably user is looking for this, probably user is looking for that, and it makes up something. And after that is what it goes with the actual weights and then comes up with the answer. Where is this happening? It's happening within the model weights. That's why we call it as a reasoning model. And there have been so many more advancements like inference, time, compute. Those things are like kind of a blend between model weights and the external deterministic system. Not going too deep into it. React loop is basically like reasoning what to do before even it does, and also after it does, reasoning whether the result it produced is accurate or not. If it is not accurate, then go back and find some other result, which could be much more probabilistic and give back to the user. And then agentic AI. So now, consider back to our thermostat example, like agentic AI is as simple as that. You have multiple AI agents, and you create an agentic system where you have like hundreds of agents working together to accomplish a goal. For example, I have a code example where, let's say you are planning a trip, and you tell to an agent that I'm planning a trip to Florida, so help me plan the itinerary. So there could be a master agent which takes this query and then breaks down into like if you're going to a trip, like what all you need flight, you need car, you need hotel, you need destinations to visit, you need better hotels on the destination, right? So instead of one agent doing this and kind of confusing itself with all these contexts and hallucinating, break it up into tasks, and it hands over the task to specialized agents. So you could have one agent which is specialized in finding destinations. Another agent like from Anthropic can be good in using a computer use and finding you a flight detail. And there could be one more agent which can, like Gemini models, which is very good at giving comprehensive text, explaining you so that you can read on the way you, about your destination as you go to the destination. So the advantage given here is, with AI agents, you're bound to one model. You have AI agent, and let's say if it is an OpenAI model AI agent, then you're just bound with one model. But let's say you want to use like multi-models. I want Perplexity for search. I need like ChatGPT for summarization. I need Gemini for like creating text. Agentic AI. So have a like a main agent, and then you have multiple sub-agents specialized in each area. So the main agent gives the task to sub-agents. The sub-agents runs through it and get back with the result. I think I jumped a lot. So as I said, AI agent gives you like autonomy. Again, AI agents are not dumb. They are not deterministic programs. Like they are agents because they take a task, they create an agency. When I say agency, they complete it like without any further help, unless they cannot proceed any further. But compared to a deterministic system, if you're not given all the inputs, it's going to just stop there. And task specific, yeah, as I told, AI agents are like, they are given a task, it just completes that task. It does not go beyond that. And reactivity, like it reacts to like what you ask to do. It does not, does by itself. On the other hand, in agentic AI, I can have an agent running behind the scenes, always listening to what I'm doing. And it can react based on that. It can kick off agents, it can take notes, it can send emails, it can create calendar invites. So this is a simple diagram that I just put together. So let's say this, we have user, gives in the prompt, it goes to the LLM, and then LLM decides that in order to complete this prompt, for example, what is the weather in Florida? So LLM really does not know what is the weather in Florida at this moment, because the weather stored in it is based on the time when it was trained. So it decides that it needs to call a tool, and it it doesn't go back to the user, but there is a deterministic component here, which calls the web, comes back with the result, and again sends to LLM, and that is when LLM, formulates that output and sends back to the user. And retrieval augmented generation, something you should already know, like documents, read the documents, chunk the documents to multiple pieces, create vector embeddings, and then use that vector embeddings and send it to LLM and correlate with the user's query and give you a meaningful output. Simple diagram. So now moving over to agentic AI, it is goal-oriented, not task-oriented. So when I called out the example of planning a trip, you're giving a goal for that agent to plan a trip, not just to book a flight. So then the agent decides to decompose the task into multiple other subtasks and then hands over to specialized agents, get the results back, collate it, and then if there are any actions need to be taken, further call further agents, and then do all those things. So goal-oriented, it decomposes the problem, and it has inter-agent communication. Of course, if there are multiple agents, it has to communicate between each other. And beyond that, let's say like I am an organization and there is so many other organizations providing specialized services. And agent in my organization needs to talk to agent in another organization. It can be done using agent communication, which is A2A protocol from Google, and we have ACP, AGP from IBM, I think. So there are several protocols. And then again, reflective reasoning. So from the output it received, it reasons. And then based on that, if the output is not satisfactory based on its previous outputs and reinforcement learning, it tries to generate another output that can convince you. And if you have seen that thumbs up and thumbs down icon in any chatbot, that's kind of helps in this. So this diagram is a little bit complicated. So same what I explained, user gives a prompt, there is an agent that comes up with steps that needs to be executed, and it decides which agent needs to be called. The sub-agents does the task and gives back to the agents. If the response is satisfactory, it gives back to the user, Otherwise, it does a React loop to keep doing the same thing over and over again. This is a very simple illustration of agentic AI. It's much more complex than this. And again, if you take an AI application, if you want to put it on one of the bucket, whether AI agent or agentic AI, that's not a really good thing because any application could fall anywhere in between AI agents and agentic AI. It's a spectrum. It's not on or off. It's not like one or two. Like it can fall anywhere in the spectrum. And an application termed as AI agent could be very well an agentic AI. Most of the coding agents today we see are supposed to be AI agents, but they are very good agentic AIs. Good, I think I'm at the end. So any questions so far on this?
When we see what did Claude code now?
Oh yeah, I'm going to go there. So it has created the application. So again, this is demo, so demo's expected to break. Don't blame me. Yeah, it break. So let's say I say Python 3, I think. Never mind. Demo's supposed to break. No, this is some other trivial issue.
Yeah, if you scroll up, yeah.
Yeah, that's what I did. So minus, I'm having a Python 3, so it's supposed to run. So I just copy.
It's all right, yeah.
Yeah, I mean, it's supposed to break. Any other questions? Yeah, we can. So survey app. So all these files were created now. So source, you have run.py. And you have roots, but there's nothing in roots because it's a one-page app, I guess. Speaker, survey, it created tests. So if you go back on the thing and let's see what it all did. So these were the subtasks it broke down the main problem into. So yeah, it created, I don't see the database though. Oh yeah, here it is. Yeah, it created the database. It's the database file, and here is the SQL. No, it did not create the DB as such. It should create in the first run. I'm sure this is to work. I've done so many, but it's supposed to fail in a demo. Any other questions?
I have a question. It seems like you're really experienced with AI and agents and stuff. I just, out of curiosity, do you believe that agents is like a buzzword?
It's not. It is real. I mean, it's a buzzword for sure, but it's getting more and more real. If you take today, we have moved past agents. We as like Kurt said, right? We are talking about swarms, and in Agentics Foundation, we are working on Hive actually.
I agree with you. It's pretty precisely defined, right? Right. So precisely defined, and it's evolving. Context is always more or less what they're talking about. I agree. Yeah. Because it's hard to sometimes it's trying to understand it. Like, would you say that like agents is the idea of almost just coding with AI?
No. Agent is a common term. Like agents can be used like anywhere. Like say you use AI and let AI to autonomously do something or do more than one task is agent. It's not related to coding.
So you would say like if I built an application that has AI in it, that is an agent? Like would you say that?
Mm,
I'm assuming something more than talking back, right? Right, yeah. Now, where's the LLM is just chatting, right? Yeah. It becomes an agent when you talk to it and then it goes off and does something in the real world outside of the conversation.
yeah. So if an application is packed, an application is so wrapped around an LLM then you can call it as AI agents. I won't call it as agentic AI. So that's the whole point this presentation is about. So use an LLM, wrap it around a deterministic program, you can call it as an AI agent because it does a specified task using a large language model. Again, as I said, it's a spectrum. Some application can also fall outside the spectrum. So if you merely just use an LLM to do like very trivial task, and if you want to call that an AI agent, it falls outside the spectrum. It doesn't even fall under AI agents or agentic AI. Exactly, yeah. You have like multiple scripts and it does like more than one task. Yeah. I mean, you don't prompt it. That's the difference. You don't prompt it. The agent itself resonates to its result and then it tries to accomplish the goal that you gave it to it. On an agentic AI, you do not give it a question, you give it a goal and it achieves the goal. So as simple as this. So that's agentic AI. Yeah. So it's a deterministic program. I mean, agentic AI is not magical. It's again a deterministic program. It houses an LLM at its heart. And agentic AI is as simple as that you have multiple systems housing like multiple LLMs within their core of their deterministic program. And they interact together. So this entire ecosystem makes agentic AI. This one, the Claude code. So this is a product from Anthropic. It's Claude code. So it uses Sonnet 4 and Sonnet 3.7 interchangeably, and it's all built by them. Like it just released like three weeks back. Any other? Yeah. Yeah. No, I made this. So, so in recent past, humans have evolved to identify AI content. I would say you're seeing so many AI generated content, primarily on LinkedIn. The glance you see at the post, you can tell if it was a human written or it is an AI generated. So it's been a month or two. I moved away from generating content in these kind of presentations and in my LinkedIn posts. I write it myself. Though it is error, I try to do that because it's very important to be human. So.
There was one typo in the word recent
Okay.
that I saw. Could we point out, is that something?
This one? Oh, okay, no. Yeah, I typed this entire thing. I did not generate. It's all typed. And again, it's not too hard to generate a presentation. So you have was a grammar app and so many apps. You just give a line, it can create the entire presentation with visuals and stuff. So it's not hard. Any other questions?
Thank you everyone for coming here. Those who are new to AI Tinkerers, who haven't listened to my spiel at the beginning, we are just like a study group outside college, like a computer club or something. We talk about AI. We are active community of builders. We want to keep this community in-person meetup going. So we usually do meetups every second Thursday of the month. We also have hackathons. We also have VIP dinners. We have different formats of events. We collaborate with other meetups in the city, sometimes and organize like even larger kind of events. But we are trying to foster the community, AI builder community in Austin. That's briefly about us. If anyone needs parking validations, please find me. I have some here. And that's a flat subsidized $8 rate for the building parking only. Yeah. Yeah, I have tried to collaborate with UT before. We have collaborated with UT Robotics, I think, lab before. We have not done any collabs with their Year of AI. I have to find that more about it. But yeah, thanks for the suggestion. Yeah, yeah. Yeah. Okay, so the app worked. Great. Awesome. Yeah, amazing. And by the way, so if you're signed up through our website, you should have networking opportunity to connect with anyone who attended this event today. Through our networking platform, you can send messages, you can post something on our message board. And please join our Discord server. Like I said, we have